Yes, so me and Tobias, we're from Elastx. So first of all, who are we? So my name is Philip Chong. I've been sort of around in this. Some people here know me, see my face. I've been at a few DevOps meetups. I'm an ex-developer, an ex-ops guy, ex-scrum master, ex-manager. Been working with DevOps and continuous delivery for about 3.5 years.
Yeah, my name is Tobias Jakobsson. I've been working with DevOps since, before it was called DevOps, I think. I love working with automation, continuous delivery pipelines, and high traffic web services, stuff like that. I've also done some Scrum Master and stuff like that as well. Yeah. So, what are we going to talk about?
Search for the Holy Grail.
So, does it exist?
Probably not. We're going to be cliched and say the journey is more important than the destination. And we're going to be full of great movie references. And I hope everyone's actually seen the movie, because otherwise none of the meager jokes we have will work.
But seriously, what are we going to talk about?
Is it possible to build a generic, portable, reusable deployment pipeline for arbitrarily complex environments? It's a lot of big words. I'll leave it on the screen for a while. We all know about deployment pipelines. We all know about continuous delivery. So this is, we'll see. We'll see if it ends up being the Holy Grail. So of course not. You English pigs.
So, who is using continuous integration today? Anyone? All right.
We want shows of hands and audience interaction.
Yeah, of course. So, who is using continuous integration on their feature branch before they merge to master? Really?
Yeah, that was almost the same amount of hands.
All right. So, who runs CI every time they push their feature to a branch? So that's...
Every time on a push.
Yeah, right. Every time you push.
We had at least a couple. You need to push a couple of buttons.
So 4 or 5?
Not bad.
So, who must pass continuous integration and code review before being able to push to master? Is anyone doing that?
Yes.
1?
2.
2?
Okay.
Really?
3-ish.
All right.
Cool.
All right. 3 persons. So, who does not use Git?
1. Oh. So, okay, it's only one poor lonely person. So who here actually does continuous delivery or continuous deployment? 3, 5, 6, 7.
Who wants to do it?
Each.
So,
lots more hands.
Yeah, hopefully almost all.
Who would say they're on the path to it? Yeah, most people. It's a DevOps meetup, so I'd expect.
Yeah.
I would expect most people. If your hand isn't up and you're at a DevOps meetup, you're probably at a dinosaur company, I expect. So, we were debating before of whether or not we should actually try to impersonate the voices, and we figured out it's better just put the words on the screen and let people read it, because we're both terrible.
Yeah.
So now we're trying to gather people into our court and for our journey towards the Holy Grail. So beginning with some thoughts on DevOps and continuous delivery. So everyone has seen pictures like this, right? So you have some sort of commit, build, deploy, test, stage, release type of thing in the deployment pipeline. If you Google for this and you look at images, this is the type of thing you see. So what happens when your system looks like this? Apache web server, MySQL, Tomcat, another Tomcat, Redis, Rabbit, more stuff. And you have like a thing, like a pop-up marker.
So anyone recognize this image?
Who works in
Yes.
systems like that?
Right.
Bunches of hands. Cool.
Mike.
Good. Great. Okay. So it could be even worse. It could be like this. Team 1, Team 2, Team 3, 4. Some third-party guys, some ops guys,
So maybe security. We don't see security. here, but
security
maybe
guys.
security.
That's present everywhere, right?
Yeah, should be.
Yeah.
So does anyone recognize this image?
It works like this.
Yes.
Yeah.
Right.
Yeah. A few people. Who works in multiple geographical locations? Time zones? Yeah. All the same people, basically. Okay. Good. Good. I think we're on
That's
target.
good. Yeah.
Okay. So most of this stuff. So the reason why I do this presentation is because why we're doing it is because most of the stuff that I look at is generally quite simple in terms of continuous delivery. I've never really found some real details about complicated deployment pipelines. The thing is, the same principles apply regardless of the complexity of the system. If you've read the book, they lay it out for you. Make it work, make it right, make it fast. Your code has no business value unless it's running in production.
So
They're very simple principles, and they should be universally applied. So changes are a multiplex of n to 1. You have multiple parallel asynchronous changes coming in from all these guys working over here, and then at some point you have to share environments and think you have a single pipeline basically out towards production. Is anyone not working like this?
All right.
What? One?
My customer, not me.
Okay. So you might have something different to this? You have
It's crap.
okay, all right. Yeah, all right, okay. But, so,
work.
all right.
You're at the right people.
I'm sure there's lots of stories about that. So the thing is, isolation needs to be achieved. Breaking stuff here is good because you're on a feature branch and you're in your own environment. And breaking stuff here is bad because you're on a shared environment on master. Sorry, I guess some people, depending on where you sit, this might obscure some of the text. Master must be gated because this is the strongest line of defense. Because all these shared resources are the things you need to protect. So this is one of the basic principles is that your master branch, whatever your mainline development branch is, that always has to be in a releasable state, and you need to protect that. And if it breaks, everyone's broken, and you have to fix it. So. So none shall pass unless your change has been approved in code review and pass testing. So this is what's interesting is that it seems to be starting to be sort of best practices, right? Everyone's starting to understand that code reviews are good things. CI is a good thing. Gated masters are a good thing. And it seems to be like universally applied, almost. And some organizations are further ahead than others. Because we all know that a change here,
Yeah. Can break stuff over there.
that's just the fact of a system like that. Which means everyone needs to be able to run this here, and 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 everywhere. Cool. So if production is complicated, so are all your test environments. So are your development environments. Not to fear. Bring the power back to development. Here's a long quote. I can drink some beer while you read it. So I had to search. I downloaded the movie, and I got all of the actual text, the entire screenplay, and I'm just like searching for keywords and trying to match them to the parts in the movie. So I hope that's not technically
I
plagiarism
think
or something.
that's how development works anyway.
Copy, paste.
Yeah.
Copy, paste. So all changes must begin over here. And I do emphasize all, must, and all changes end up here. Of course, right? Makes sense.
So if the ops teams are doing some upgrades on something, it begins here, right? Should not be done in staging or prod first. They should have their own set here, and then have it pass the test and stuff like that, so they can merge to master for their stuff.
Only exceptions to this rule are security, legal compliance, or prohibitive cost. And I had to spend some time on this slide to actually try to think of all the exceptions, and I don't think there are any more. I don't think it's not enough to just say, I didn't get around to it, it's technically complicated, it's okay. If it's cost-wise, sure, but I don't think there are any other exceptions to this.
The definition of prohibitive cost, right? Someone might say that this costs too much, and they don't see the full picture of how much it does cost to actually break our line of defense.
Well, the interesting thing is if you're using something like Amazon or whatever, something where you actually have a cost to all your instances, all the resources that you're spinning up, and you get a number cost, a krona dollar cost or whatever, as opposed to using things like internal clouds where you have actually much more a cost if you're going to do it internally, but all the costs are hidden.
Yeah.
It's the difference basically between private and public clouds. But it's just a flesh wound. So this is a question,
Yeah.
an actual, not a rhetorical one. How many directions does a fluid flow in a pipeline?
Anyone?
One.
Yeah.
All right, good. Consensus from our two. So, deployment pipelines demonstrate why silos are bad. So you have developers over here doing some change management. They work on application code. You have some QAs kind of in the middle here. They're doing some change management for test code. And you have some ops guys over here. Remember, they're writing some Puppet stuff or some Chef stuff. So who works in an organization like this?
Where you have
Yeah.
an ops team, and you have a dev team, and you have a QA team, and they all work at different parts of the pipeline. So you recognize this picture as well.
So if you have infrastructure changes out here, do they? What is the test environment for ops guys?
Production. All right. Yeah, let's do it live.
It leads to this. You have code flowing this way. You have code flowing that way. You have code flowing this way. And you get this every time you integrate. Everyone's familiar with this scenario, I guess?
I guess people quit their job before this happens often.
Yeah. Have people... Everyone's seen this movie, right?
Yes.
Do they remember what happened before this part? I don't know what happened. It is like the most ridiculous part of the movie where they're singing and dancing on tables. I think it's the only part where, yeah, anyways, all right. I watched the movie like 3 times before, like trying to get like all the quotes and reminding myself. Anyways. So collaboration on changes are required. So we start with the user story. As a Knight of the Round Table, I want the Holy Grail, so that... Does anyone know how that ends? Why do you want the Holy Grail? I think we're mixing movies.
No.
Whatever. I don't actually know why the hell you want the Holy Grail, but anyways, whatever. And we have acceptance criteria. The Grail must be unique. Grail must be in the shape of a cup. Grail must hold liquid. I must be able to drink from the Grail. And I must be granted immortality after drinking. Who actually writes user stories like this? No hands. Yeah.
No
right.
hands?
So I'm also guilty of this. I think this is one of the, like, you always rush through this stuff, and I think that this is kind of like, it's one of the parts of, like, I think you sort of like need to refine, and I'm only starting to understand more about why you need to do these really silly things and document all these silly things. The more stuff that I actually research and actually try to learn, why the hell does everyone say you need to do these things? There's things like this. Acceptance criteria form the boundaries of function and basis of testing. So that's important. I think we can all agree that's important. That's what your acceptance criteria is supposed to define. So, separating implementation from test code, but collaborate on changes. So here is an example. Your repos probably look similar, maybe quite different, I don't know. So you have, I don't know how many types of repos there are. I was actually trying to figure this out, and so how I group them is kind of 4. So there's obviously your application code. You have your configuration code, which is going to be your Puppet Chef type of stuff. Test code. So if your application code includes unit tests, and then your test code is probably containing system tests, integration tests, these types of things. And maybe, or maybe not, you might have some test framework which does some stuff to do like parallelization of tests and those types of things. So our collaborators, in the example we're about to see, are going to make changes in these two. A very typical kind of user story, new feature, new tests. Is it inappropriate to drink a beer in the middle of a presentation?
No, it isn't.
No, okay, it's a DevOps meetup, it's fine. Good. So we have 2 people in 2 repos using the same branch name for the same story. If I repeat that again, but no, like, so we're going to go through an example of how we're doing it, my current customer. How do you collaborate between developers, testers? Could be ops guys. They could be writing CF engine code. The Knights of Ni, possibly the worst Monty Python skit in all their movies. Oh, was that contentious? All right, okay. We shall move on. So our story begins. The developer writes their unit test, commits, and pushes the remote. No code, no application code actually been written yet. The tester does the same thing with their functional tests. And you might have someone else who can review and comment on the push code. And I put this in a parenthesis because there's an idea, obviously, behind why you might do it that way. And why that links back to the user story. Why do you do your acceptance criteria? And TDD is a way for designing software. But anyways, this is more kind of like academic talk. If anyone wants to talk, if anyone has greater ideas or things about this sort of stuff, I'm certainly interested to talk to them afterwards, because I have some stuff. Ideas. Nothing implemented yet. This is one of the search words that I came up with, kind of going, all right, at what point are they entering things? Okay, at some point there's a cave. This is the thing that actually has the killer bunny, and they have to use the holy hand grenade. I couldn't figure out how to use. I could have used the holy hand grenade, I guess, with the nuclear explosion in the pipelines instead.
Well, we'll say we accept patches to the presentation.
I'll open source
we'll
and
review
post
it
in
before
the
we
Meetup.
push it to mainline, of course.
So here is an entry point. So we have a vagrant file. So here's an example. We have an application source repo and a branch, and a test case repo and a branch. These are just read from the shell environment. And so every user running Vagrant can basically define what it is that they're working on. So we have more user-specific variables. such as the username. So we just pull out whatever, and sometimes this appears as things like root. You're like, is that the normal user that you have on your system that you do stuff as? Or have you done something strange, accidental? Anyways, of course, a domain name, which is not coming from the shell, but anyways, Amazon key pairs, whatever else. Any type of user or environmental level customization in the Vagrant file. And we have machine definitions. So this is just stored in the most simplest form that you can basically do it in a Vagrant file. Who uses Vagrant? Yeah, about half the room. Okay, so everyone at least should be familiar with Vagrant files then. And so this example, we have a master, which is a Puppet master, and then all of our other boxes are basically agents. So we have two base images: Puppet master, Puppet agent. This box, master, also contains a Jenkins slave, so it's both. So it's a master for the environment that you're building, but it's also a Jenkins slave when it comes to continuous integration. Packer is used to build the master and agent boxes to speed up provisioning. That's a step I skip. That's basically all done before this stuff. Here, this is a little bit of a hack, but it works. And it works pretty well. So the reason why we include Jenkins, so this is the Jenkins master. There's a box definition. And the reason why we have this is so that we can do Vagrant provision Jenkins. And when you do that, you end up with all your Jenkins jobs. And so that ends up being populated with the same user and environment specific variables. And you'll see some screenshots from that. But of course, you don't want to do things like up, suspend, destroy on your Jenkins master. So you have to protect it in some ways. And it is protected in more ways than just disabling the commands. You actually get big red ugly errors on doing anything without. This actually is a Vagrant plugin that you actually need because it intercepts the Vagrant commands. Anyways, we need that to create our Jenkins jobs. We have a single Ansible provisioner. We have a single entry point called the site YAML. Does anyone use Ansible? Cool, good. Ansible with Vagrant? No? One? Okay. You were saying your stuff was messed up before.
Yeah, you said correct.
You have a long road ahead of you.
Different customers.
Okay. So this is, so if you're not familiar with Ansible, this isn't going to be an Ansible talk, but the reason why we use Ansible is because it's really nice as a push-based mechanism. So it's not so as in contrast to something like Puppet or Chef or whatever, where you have this master-slave stuff. Even though in here, if you remember the previous diagram, we did actually have a Puppet master, so we're using these tools in combination, which is basically what I'm saying here. And so you have some best practices, which is pretty nice because Ansible's pretty simple, which is why I like it. And it defines it. You can go to the Ansible documentation, and it says here are the best practices about how to write Ansible playbooks, and it's one page. And that's it. Find me the one page for Chef. So once the developer writes code that passes unit tests, it's time to Vagrant up. So we up the master on Amazon.
How many has used Vagrant not locally, but with like Amazon? One?
Mm-hmm.
How many knew that you could run Vagrant outside your local machines? Not many, right?
So then who uses Vagrant but just on VirtualBox or something just locally? Okay. How many machines can you actually spin up?
If we looked at the earlier picture, could you do that, all that?
Yeah. So next, then you can up all these things. By the way, okay, we promised we wouldn't sell anything. The same thing works on things like OpenStack. You can do stuff on, Vagrant. Sorry?
Yes, and CloudStack.
And CloudStack, yes. Actually, when I was at Klarna, are you a Klarna?
Yeah.
Yeah, okay. That's why you know that. Because we actually had to fork, it came from the Amazon, no, it came from the OpenStack. Actually, I'm not sure what plugin that originally came from. Maybe they wrote themselves? I should know that. I think it was my team who wrote it. My old team, a couple of years ago, when I used to work there. Anyways. So once the master is up, of course, you can bring up the rest of the servers, and then they will turn into your MySQL, web server, whatever they are. And then Vagrant provision Jenkins, and this creates our jobs. Right, so we create our environment, and then we spin up our jobs. Our servers appear in EC2. And so you can see here, and there's clearly obscured text and all this sort of stuff. So one of these, I can't remember which one, there's a couple of different instance types. One of them would be the master, and the other ones would be the rest of the system. And we just tag it with my name. So every user, so depending on how many teams you have, how many users you have, and this is your shell, this is your user shell environment variable that comes out here.
Hopefully not root.
Hopefully not
Right.
root, but it was yesterday. And I was like, who's that? And thankfully their SSH key was their actual username. And I was like, do you normally run as root? Anyways. So when you bring out the master, who uses Jenkins? Most people, good. So everyone should be familiar with this GUI at least. So on your build executors, who uses Jenkins slaves? Most people again, okay, good. So then you know the master, basically, so most of this is kind of default configuration in terms of the slaves. So you end up with 2 build executors. Here is some guy with their master, which has the Jenkins slave in it. And here's some guy called EMT. Here's some other guy called Phil, whoever that is. Here's some other guy called Temp. These pictures are a little bit old because they're from February when I was playing around with numbers of build executors and these types of things. And the way that this works is we use the Jenkins Swarm plugin to automatically connect. So already in your base image, you have the Jenkins master, and it starts the Swarm plugin as a daemon, and it connects like this as soon as you do Vagrant up master. So this is where you do Vagrant provision Jenkins. So these jobs, which are, wrong button, let me go back. User-specific, environment-specific jobs. So again, I've obscured some names. You have, notice they're called build, deploy, test. I like what our deployment pipeline looked like at the start. They all have our username in them, and they're actually all locked to my build slave. So at this point, we still don't actually have a running environment. We basically have idle virtual machines because we only get a working application after it's built and after it's deployed, obviously. But this is really part of the development workflow, right? For demo purposes, it might be useful to do all this thing immediately in Vagrant up, but that's not how you work as a developer. It's not how you work as a tester. It's not how you work as you're doing CF engine changes, Puppet changes, whatever. So here's an example of a Jenkins job template. So there's the Jenkins job builder, which is a thing that the OpenStack guys actually maintain, and we use that. You can see up here, which is a cat. So this is inside the Vagrant repo, where you have roles, Jenkins master, templates, web server build. So this is one stage of a deployment pipeline, which is the build stage for our web server. So the job is fixed to our master username, holygrail.net. it will take in these originally will come from shell environment variables. So your source, which will be your Git remote repo and a branch. And it will also trigger some downstream jobs. So your build job, after that you want to deploy. And so that template that we looked at might build one of these boxes. So you have a number of these, and then this will be the deploy job, which is a downstream job. And then you'll use this test job, which is another template. And when you vagrant provision Jenkins, it builds this whole thing. And you can parameterize it, you can configure it, you can say, I only want this pipeline, not all of these things, because each one of these is, for example, a web server, or an API server, or this other server, or some other server, or whatever the hell is in your system. Whatever your stages should be. I don't know, should a MySQL, should a database have a deploy stage, a build stage, I don't know, whatever it is, whatever your environment looks like. So conceptually now, this is how it looks in our pipeline. So developers change, passes unit tests, and is now ready for functional testing. So this is probably done locally. Maybe you have some Git commit hook or something like that, make sure the unit tests are run. So someone else, a tester, writes some functional tests. So this is code in another repo. They probably don't have any unit tests, which is why the box disappears. So again, we're still working on the same story, right? The same feature. We want to have additional tests available. So that once the merge is approved, we have to merge both branches into masters, into their equivalent masters at the same time. Because it basically needs to be an atomic change. But they need to be tested together. And probably to begin with, you're going to fail. So the developer's change runs against the QA's functional tests in the environment that we've built, but we're not yet feature complete. So now you need to iterate. So both the developer and the tester can do this together. So the flow of CI in your feature branch is
Change push, change push, change push.
right. And basically you just have a webhook. So every time you do a push, Jenkins will just run the build. So here's another odd question as well I like throwing out. Who commits codes more than once a day? Good. Who pushes at least once a day? Okay. Well, good. All right. Great. This workflow will be fantastic for you. So the idea is that the solution is that it's suitable for one person changing one repo in one story, but it's also suitable for multiple people changing multiple repos. But again, we're still working on one story. This is how you're going to get ops, testers, developers all working together. It can affect multiple components because you probably have roughly one repo to one component or one server, maybe, something like that. So these aren't issues basically in what we have because you can reproduce the entire system and test all of those changes all together, all at the start of the pipeline. So it's designed to scale for collaborative changes between developers, testers, and ops. The collaboration also occurs this way. This is communication. Doesn't exactly make sense, all of it, really. The point is that the ability to configure your environment, to customize it, to say, I need to collaboratively work with this guy, and so we're going to work on the same branch name, are going to work in different repos. But you might also have issues, which is something like a transitional phase, where you might have horrible things called something like an epic release or an epic branch, which is months and months and months and months worth of work. And you have multiple people who have been doing all sorts of stuff on those branches, and you're going, well, this is all lovely, the continuous delivery stuff. That'd be great if we can have short branches and short stories and you can push of a button and get all this stuff out. But what about all of our months and months and months and months and months worth of work? Once that's merged, these are your bombs in your pipeline. So how do you provide safe isolation for those types of changes, for dealing with a transition in an organization, and getting them to test everything together without locking up a shared resource, which is, in the previous diagram, I think, was it CI? This is probably not exactly a CI environment. Maybe it's just a shared environment where there's a whole load of manual testing. Right? And you wait for that release to go in there, and then it breaks everything, and then it does database changes, and you have to roll it back because it's only testing stuff, and it was never actually supposed to be released. And everyone familiar with those scenarios? But doesn't this mean we break isolation if we're doing this stuff? No. So by isolation we mean on a feature branch before we merge to master. So once the story is feature complete, approved in code review, passes testing, then it can be merged to master. Everyone loves that scene, right? I think I was like, must have been like 12.
You had
10, 12?
you had a lot of images from this one.
This was the first time I saw it. And I was like, yeah.
We talked about kill your darlings, and a lot of images from this scene were deleted.
Don't kill them, just chop off their arms and their legs and cut them in half. So we should automate these stages, of course, as well. But at the moment, we really only kind of talked up to here. So this is a little bit controversial. I do know why. I advocate fast forward only merging to master. Does anyone do fast forward only merging to master? Or your, I don't know, whatever your mainline development
One?
is? No. So everyone accepts recursive?
Could you maybe please elaborate a little bit on what that means?
So fast forward, so if you're on a feature branch and you actually want to do so somehow you're going to merge that branch to your master, if Git will it depends on the Git implementation you use. So we're actually using Stash. Its default implementation will always do a recursive merge, which is kind of shitty. So it even means that the difference between a fast forward merge and essentially a recursive merge, which is usually the two that you'll deal with, is fast forward is that the head of, I don't know, we're getting real technical. The head of the branch that you have, that you are trying to merge a change from, it will be successive commits. So it won't end up with an additional merge commit. If you have a recursive merge, you'll end up with a special commit called a merge commit. And that's the one where it says, Git will actually prompt you with the commit message saying, here's these merge commits. And they're generally kind of considered ugly. The fast forward merge is where you don't get the merge commit. So what you looked at, if you looked at a branch, you would just see a consecutive set of single commits in a single branch. And you wouldn't, if you looked at it on a tree, you wouldn't see these branches that appear and get merged back. So that's the difference.
You can come to us and we can talk more about that. Yes, later.
It's actually a really interesting topic. It gets in a lot of the details of Git. But there's really a lot of good benefits, and if you really are trying to, if you really need to make changes in an organization, this is a thing that will drive people nuts, but it will definitely drive change. and I can explain.
So concretely, what you want to achieve is that there's no surprises when you merge the master, right? That's what we're talking about.
The impact from this is that it will force people to rebase.
Exactly.
It will force people to have the latest commit from master in their feature branch before they can actually merge to master. And that's what you want in continuous. That's the integration part of continuous integration, because you need to keep your master branch always releasable. So, but if people branch and never try to rebase or never try to merge, pull the latest changes from master, it depends on your branching strategy, right? They might, if they're doing a pull, they can do a recursive merge, and you can have all this sort of stuff. There's lots of options here.
There's some crazy people who release from the feature branch as well, and actually say that's a good idea.
Oh yeah.
How many do that?
Yeah, you just say like here, just. It's because you don't worry about the branch. You just say here's a tag.
Yeah, it works.
Check out the tag, deploy that. Doesn't matter what the tag is.
I think the thing is that you want to be sure that the master branch contains something that you have already tested.
Yeah.
Well,
So yeah.
Not a potentially broken branch.
Yes.
Yeah. So the master should always be in a releasable state, basically.
I mean, you can't say that you have changes under control if you can just have a tag on any commit in a repo. That's not control changes. You can't do continuous integration, let alone continuous delivery, with no control over branches. So just remember that your code has zero business value, and it really, really does. It has absolutely no business value. Your paycheck that you're actually getting every month, if your change doesn't get out to production, it is bringing no value to the business.
So basically, when you have your Scrum board and you say that I'm done with this ticket, we've passed all the tests and everything, I'm moving on to the next one, and that is not merged to the mainline master, then we're not getting any value from that at all. You cannot continue with your next feature branch.
So finally, a short note about DevOps toolchain. Oops, that was a bit fast. DevOps toolchain. Choose wisely. That's what happens if you choose wrong. And we're about 45 minutes, so we're going to go a little bit fast on the end of this stuff. So the point of this diagram was, and the circles behind these things is really illustrate, this is a Venn diagram, and there's overlap between a lot of these tools. It's a mess out there.
But it's a great mess.
If you work in this space, it's kind of like, oh, what does this one do now? Why is it all on Hacker News? What does it do?
So that's what we're spending our weekends on, right?
Yeah.
After work, we go and try the new tools. Yeah.
So I think this is one of the biggest challenges in DevOps at the moment, is just keeping track of all this mess. So most problems aren't new. There's almost certainly a tool there that helps you solve it. The difficulty is knowing what tools are out there and understanding how well it fits your problem. And that's a big problem. That's a significant problem. Otherwise, you start reinventing stuff yourself, whatever.
So what do you think? Have we found the Holy Grail?
I don't know. All right. Cool.
Thanks.
Thanks.